Hi everyone, welcome back to the channel. Today we're going to be using the Spike Prime and Pybricks block coding to control the heading of the robot using the gyro sensor built inside the Spike Prime hub. Let's go ahead and look at the code. So typically, you'd have your robot set up using your left motor and right motor and then your drive base. I've named my drive base Jeff. You have your setup of a wheel diameter and your axle track. And your axle track would typically be the part that's controlling how your robot is turning. Now, we can use this one simple block right here, drive base, use gyro. Populated the drive base named Jeff. And then the robot is going to control its heading using the gyro sensor. If we click on this drop down menu, we can toggle between use gyro for turning and driving straight, or use sensors, or use rotation sensors for turning and driving straight. Let's go ahead and take a look again what the rotation sensors for turning and driving straight looks like. Grab this. I'm going to go ahead and grab a drive straight for 250 millimeters. Let's swap back over to the camera. Put our robot right here, and then I'll start the code. Now, if I boop the robot, it continues in the direction of where I've booped it, so the heading continues going in that direction. There's nothing used to control its heading. If I go in the code and I swap over the rotation sensor to use gyro, then I will swap back here, test it out. You can see that the robot is auto-correcting itself and trying to stay at that heading that it started at. So it's starting heading in this position. We click start, and it corrects itself. I'm going to go ahead and increase that distance to, say, 5,000 so we can really take a look at what's going on here. As you see, when I turn the robot, the wheel slows down, this wheel speeds up, causing it to turn back towards the direction of where the original heading is. Do the same for the other side. And you see the robot actually spins this wheel backwards at a certain point, so it tries to stay on that center line the whole time. There we go. Let's go ahead and take a look inside the code. We can see how to do the same thing for turning. So let's hit a curve by a given radius. Its goal is to get to 90 degrees. And if I go ahead and click start in the code, the robot should turn 90 degrees. And then if I click start again, the robot's going to keep going until it's reached that 90-degree value. It's not able to detect the radius like this, but it is able to detect where the robot's heading is going to be. So you still have to make sure that your wheel diameter is correct. You don't actually have to worry about your axle track anymore. I'll prove this by looking at the code. We can see I'm going to put this as 500. So my robot is super duper wide now. And I will go ahead and run this code for you. Our robot still goes until that heading position. Now everything seems a little bit messed up because it thinks the robot is super wide and it's trying to get to that position. Try not to overshoot it, so it's compensating for it for a little bit. So still trying to get your heading or your axle track as accurate as possible will still help your speed and accuracy of your robot. Switch it back to what my robot set to. Click start, and it goes to that heading position. Thank you guys so much for watching the video today. Honestly, with tools like this that Pybricks has given us, I think everyone's robot is going to be super accurate, super fast, traversing around the fields with incredible accuracy. They've really given us a lot of tools to make this easier and easier to learn. What I'd like to do in the future is put out another video exactly the math behind how the gyro sensor is working and how it's controlling each of the motors, and we can actually go step by step on the blocks. So if you ever get to a position in your judging interviews where you're asked how the gyro sensor works, everyone should be able to know exactly what's going on. Well, thank you guys so much for watching this video. Don't forget to like and subscribe, and we'll see you in the next one.